Everyone, so today we are going to discuss one of the important interview question, that what is the gain of this figure 1. Then there is a cross question, then why the same thing is not happening in the second case. So the game, let's see the first circuit. What will be the gain? To calculate the gain, just identify this configuration, which is common source with degenerative resistance here. So as we know, for common source with degenerative resistor, our gain comes as minus gm rd upon 1 plus gm rs, where rs is the degenerative resistor which is connected to your source terminal. This is your source, this is your drain, this is your gate, and rd is the resistance as the drain. Here if we say this is ideal current source, then rs will obviously be infinite, very high, so av will be 0. This is one way to say that the gain of this will be 0. We are taking out from here. Okay, now another way to understand it is like whenever we have ideal current source here, this VDD is DC source, then ideal current source DC source, and RD is constant, ID is also constant, so this VDD minus RD will also be constant. So this complete VDD minus RD here it is constant. So for small signal we can say that this become grounded. So this ideal current source here makes this terminal as constant, so it will not vary with change in input voltage, because this become AC ground, so our gain AV will be 0. So this is the simple question. Now the cross question arises, why we say this is a differential pair, it has a gain AV is equal to minus GM into RD. So the answer of this is because this is a differential gain. This is differential gain which will come GM into RD, while the same terminology will come when we treat the, or when we will calculate the common mode gain of this. Then it will be, obviously in case of common mode gain, we will apply both same voltage at both the terminal. So how it will, the equivalent circuit will become like this. This will become like this. This is your current source, and this is your RD, this is your RD. One MOS is this, another MOS is this, BCM is applied here. Now with this, this circuit will be like this. GM will become twice GM and this. So now we can say that the common mode gain in this case will be equal to 0, because this circuit now become same as this one. And if we will calculate the common mode gain here, it will be 0. So whenever you are designing, if you need very high CMRR, which is your CMRR, if you have CMRR spec, so CMRR is always equal to AD by AC. It means we have to increase AC to increase CMRR, to decrease CMRR. So to increase CMRR, actually we need high CMRR ideally, so we have to decrease AC, which is common mode gain. So to decrease the common mode gain, what we need to increase? RS, or resistance of this current source. So how the differential gain come? Minus GMRD, that is we need to see the differential mode analysis, so that we will see in another video. So here we can understand like this. I hope it will be helpful to you. Thanks.